Imagine you are in charge of a colossal, modern, 100-story apartment complex. Thousands of people live there. But for some reason, this massive building has exactly one standard-sized front door for everyone to use. In the early days of cloud computing, developers had a digital version of this exact setup. It was a tool called Ingress. Its only job was to act as that single front door, letting internet traffic safely inside the network. When the apps were small, that was fine. But as these digital buildings grew to house hundreds of complex programs, one simple entryway became a bottleneck. It had no way to handle security checkpoints, fast-track VIP lines, or even a way to stop a sudden crowd from flooding the lobby all at once. This diagram shows the old, chaotic workaround engineers had to use. To force Ingress to do complex tasks, building managers had to duct tape paragraphs of highly specific instructions directly onto that front door. When you force a single basic entryway to handle the complex routing logic of an entire skyscraper, the system becomes incredibly fragile. One small mistake in those instructions, and the whole door breaks. To make matters worse, managing this digital building involves two different groups of people. You have the platform engineers, who manage the physical building, and the developers who run the individual apps inside their apartments. Under the old Ingress system, both of these teams had to share that exact same messy file. They were trying to write their specific instructions on the exact same piece of duct tape at the exact same time. As a result, teams constantly bumped elbows. One engineer might update a routing rule and accidentally overwrite the other team's security settings. Suddenly, visitors couldn't reach their destination. The creators of Kubernetes realized this setup was unsustainable, so they designed a modern solution called the Gateway API. It rips down the messy tape and reorganizes the entryway entirely. For a massive system to actually function, you have to separate responsibilities. By giving different teams their own specific workspaces, they can do their jobs without tripping over each other. This diagram maps out the new approach. Instead of a single file, the Gateway API divides the job of internet traffic management into three clean, separate pillars. The first piece is the Gateway class. Think of this as the building's electrical foundation. It is installed once by the building manager to power everything else, and the tenants never have to touch it. The second piece is the gateway itself. This acts as the physical door structure. It simply decides if an entryway is open to normal visitors, or if it should be locked down for secure private guests. The final piece is the HTTP route. You can think of this as the mailroom director. It is completely controlled by the individual tenants, allowing them to route visitors directly to their specific apartments. By giving the foundation, the door, and the directions to three separate owners, the Gateway API neatly isolates the moving parts. Teams no longer run the risk of breaking each other's code. That third piece, the HTTP route, is the most powerful tool in this new system, because of how smoothly it handles the daily needs of the tenants. Imagine a tenant decides to move their takeaway restaurant from the front of the building to the back. In the digital world, that means changing their web address, which usually breaks old links and frustrates customers. This graphic shows how the mailroom director solves that. It quietly intercepts old visitors who are looking for the original red address and smoothly reroutes them to the new blue location at the network level. The customers never hit a dead end, and because the handoff happens instantly behind the scenes, they do not even realize they were redirected. This feature allows developers to completely reorganize their internal apps and folders without ever breaking old links or confusing their users. Let's look at a second, riskier scenario. It is a process called canary routing. Imagine a coffee shop tenant wants to test an experimental new recipe. They're terrified of rolling it out to everyone at once, because if it tastes terrible, they ruin their reputation for the whole day. This flowchart illustrates exactly how canary routing protects them. The mailroom director splits the main flow of traffic, sending 80% of customers straight to the classic recipe, while a narrow 20% path safely branches off to test the new one. If complaints start coming in about the new coffee, the tenant can instantly shut off that 20% stream by changing a single number. No messy duct tape instructions required. This precise traffic splitting allows tech companies to test dangerous new ideas out in the real world without the fear of taking down the entire system. If we step back from the apartment metaphor, This giant building is actually a complex Kubernetes cluster running modern software on a server. The tenants are the actual applications running on our phones and laptops, and the visitors walking through the door are our daily internet requests. When an app magically updates its layout without crashing, or you suddenly get early access to a beta feature that your friend doesn't have yet, it isn't luck. That seamless experience is entirely thanks to the Gateway API, acting as the ultimate digital traffic director in the background. Truly robust internet infrastructure relies on its ability to elegantly guide billions of daily interactions to exactly the right place at exactly the right time. Technical terms like clusters, Ingress, and APIs can make cloud networking sound impossibly intimidating to learn. But when you strip away the acronyms, these technologies are just solving basic human logistics. They are organizing traffic so people get what they need. Moving from a chaotic, single front door bottleneck to a brilliantly divided three-part system makes the internet faster and safer to build on. Clear rules and divided responsibilities are the secret to scaling anything effectively, whether it is a 100-story apartment building or the architecture of the modern web. Even the most complex digital infrastructures operate on beautiful, easy-to-understand logic. Once you see the patterns, you can build anything.